Hi, welcome to my channel Mathemagic with Mohsin Raza, and today I am come up with a question that says that we have a sequence that is satisfying this recurrence relation, and that recurrence relation is xn plus 1 equals to 3 under root xn minus 1 over xn plus 3 under root, where n is greater or equal 1, and we have to prove that the sequence is periodic. Okay, before doing this, if you haven't subscribed yet, so please subscribe my channel for more interesting videos. So let's how to tackle such kind of questions that comes in a mathematical olympiad, and what does mean by proving the sequence to be a periodic. So first of all, I will recall the definition of the periodic function, and that periodic function definition is that if we have a function f of x, then if we could find a some number p, which is let's say this is greater than 0 and this is the smallest number p, such that f of x plus p is equals to f of x, and this is the smallest number. So for the examples, and then this p is known to be a period for this periodic function, because this is repeating its values after some interval. So for example, if we have a function tangent x, then we can see that the smallest number that can be added to x, and then tangent function repeats its values is pi. So that's why tangent of x plus pi is the same as tangent x. And similarly, if you look the graph of the tangent function, then it follows this, that after the interval of pi it will repeat its values. Okay, now we come up to our question, and that we have a sequence, and that sequence is saying this is xn plus 1 is equals to, and I can write this sequence in a form of like by dividing 3 under root. So what we get? So we get here xn minus 1 over under root 3 over 1 over under root 3 xn plus 1. I hope there is no confusion, because we are just dividing 3 square root in the numerator as well as in the denominator. So now look that we use the identity, and we use the tangent property that I have told, that tangent is also a periodic function, and we show that this sequence is also a periodic. That's what we need to show. Okay, so first of all, you remember that tangent of pi by 6 is what? This is 1 over under root 3, right? So that gives what? That gives xn plus 1 equals to xn minus tangent pi by 6 over 1 plus xn tangent of pi by 6. Okay, so now look what is going on. So let me rewrite that expression again, that is xn plus 1 is equals to xn plus tangent of pi by 6 over that was 1 plus xn times tangent of pi by 6. Okay, so now you remember that we have an identity which says that tangent of a plus b, that is a sum of the angles of two different angles, then we are applying the tangent function to the angle, then this is the same as tangent a plus tangent b over 1 plus tangent a tangent b. Okay, so if you plug x, now if you plug n equals to 1, then what we get? We get x2 equals to x1 plus tangent of pi by 6 over 1 plus, and here that is again x1, and that is tangent of pi by 6. So here this is naturally that we can take x1 to be a tangent of some real numbers, because this is x1 is number and tangent has a range over all the real numbers. So whatever the x1 will be given, we could find the t such that we could write x1 to be equals to tangent t. I hope you have no confusion in it, because whatever the x1 is given, because the range of the tangent function is the whole real number, so we could find t, and that could be between minus pi by 2 to pi by 2 even. We could find that t, and for which x1 can be written as in this form. So from here we get what? So that will be, and by using this identity, that will be equals to tangent of that is t plus pi by 6. So I hope you have no confusion in it. So now what about x3? So x3 will gives x2 plus tangent of pi by 6 over 1 plus x2, and this is a tangent of pi by 6. So if you look that this is also given in the form of the tangent function, that is tangent of t plus pi by 6, and this is another function which is tangent of pi by 6, and by using this sum identity we could write that x3 is nothing but tangent of t plus, right, and 2 times pi by 6. So from here we can have a general formula for xn. So the general formula for xn is what? This is tangent of t plus n minus 1 times pi by 6. Okay, so now we have to look what actually n to be added, that because this is a function, this is a function of n, which is f of n, and what should be added to this n to make that function to repeat itself. Okay, so how we can do this? So we use the periodicity of the tangent function, and we will see what actually the adding to n to repeat itself. And so you can think of this f of n, or even you can write this like an xn. So let me write it again. So xn is tangent of t plus n minus 1 pi by 6. Okay, and we know one thing, that the periodicity of the tangent function is pi, which means that what it gives, this gives that tangent of t plus n minus 1 into pi over 6 is the same as tangent of t plus pi into n, no sorry, plus n minus 1 over 6 pi, right? And what it gives? That gives tangent of t plus, and this is what? This is actually n plus 5 pi over 6. And which term is this? This is actually xn plus 6. So this was what? This was xn, and by using the periodicity of the tangent function, that its period is pi, so by adding the pi in the argument of the t, because that is function of t, and when we add it, so then it will give the same value. So by simplifying, we have seen this is actually the xn plus 6. So from here you have seen that actually we are getting xn plus 6 is equals to xn. What it says? This says that the given sequence that we are discussing is the periodic. So from here xn is periodic, and the second thing is that the period for this sequence is what? And this is 6. Okay, is 6. Okay, so thank you for watching this video, and for more interesting videos please subscribe the channel and keep tuned with me. Thank you so much.